Good morning. So today I'm going to continue solving some more sample problem in chapter 10 of Himmelblau. So in this video, I will tackle the element balance. So element balance is a technique used to solve generally problems in mass balance with chemical reaction. So in this particular example, I will try to find out the stoichiometric coefficient of the reactants. So using elemental balance. Let me share the PowerPoint. Okay, so let me read the problem. This is example 10.6. Okay. Hydrocracking is an important refinery process for converting low-valued heavy hydrocarbon into more value, lower molecular weight hydrocarbon by exposing the feed to a show-like catalyst at high temperature and pressure in the presence of hydrogen. So basically in this problem, we're going to convert octane. Octane is C8H18. It contains 8 carbons into C3H8, that's propane, C4H10, that's butane, and C5H12, that's pentane. So generally, this low molecular weight, low carbon hydrocarbon are used to make monomers of polymers. So polymers, these are plastic materials, So generally parang mas mahal yung plastic kesa octane, So researchers in this field study the hydrocracking of pure components such as octane, CH18, to understand the behavior of cracking reaction. In one such experiment for hydrocracking of octane, the cracked product had the following composition in mole percent. 19.5% C3H8, that's propane, 59.4% C4H10, that's butane, 21.1% C5H12, that's pentane. You are asked to determine the molar ratio of hydrogen consumed to octane reacted for this process. So, basically, ang tinatanong niya yung stoichiometric coefficient ng hydrogen at saka ng octane sa balance reaction. So, generally, in order to solve this kind of problem, probably a practical basis would be to use 100 moles of product. That means you will have 19.5 moles of propane, 59.4 moles of butane, and 21.1 moles of pentane. So after that, kasi nga ang topic natin is element balance, we're going to perform carbon balance and hydrogen balance. And then, if you can imagine, there will be only one unknown for each equation. So for carbon balance, your only unknown would be the number of moles of octane in the reactant. And then for hydrogen balance, if you know the number of moles of octane, the only unknown is the number of moles of hydrogen gas. So since the question is the molar ratio, you just simply divide the number of moles of hydrogen with the number of moles of octane. Basically, ganun lang naman kadali yung problem. Okay, let's try to solve this. Okay. So first, our basis. We're going to assume that there are 100 moles. Parang nagre-record na ako, kita ka. Parang nagre-record na ako, kita ka. Okay, 100 moles of product. uh, so that means you will have 19.5 moles of C3H8. 59.4 C4H10. 21.1 mole C5H12. Okay. So basically, yung atin namang diagram, papasok si octane. So let's call octane as F, kamukha sa libro, ano? Parang siguro P dito, ano? Papasok yung octane. This is C8H18. So F is here is the number of moles of octane. And then papasok din si hydrogen. Let's call that H. Actually sa libro is G, ano? Parang gas. So H na lang, H na yung sulat ko. So this is for hydrogen. Papasok siya dun sa combustion chamber. Tapos lalabas yung tatlong product. Ano? Si C3H8, propane. Ang C4H10, octane. Butane. And C5H12, pentane. So, as earlier, I'm telling you earlier that all you need to do is perform a carbon balance and then hydrogen balance. Ano? So I guess first let's try to perform a carbon balance. Kasi sa carbon balance isa lang yung ano. So you can solve F. So let's perform a carbon balance. So that would be F times 8 or 8F. Okay, itong isa wala naman siyang carbon, so hindi na siya kasama sa equation. Tapos equal na siya sa you have 19.5 mole of C3H8, so that would be 19.5 times 3. Plus 59.4, okay, times 4, plus this one, 21.1 times 5. Okay. Just simply get your A calculator and try to find F in the zip solve function. So I'm getting 50.2. Okay. So F is equals to 50.2. So that means you have 50.2 mole of octane, ano? C8H18 for every 100 mole of product. Okay, on this side, we're going to perform hydrogen balance. So we're going to draw a line. Tapos we're going to perform hydrogen balance. So hydrogen balance, we have F times 18 and our F is already, we already know F, ano, it's 50.2. So it will be 50.2 times 8, 18. 18. 18 times 8 times 50.2. 18. 18 times 8 times 50. 50.2 times 8. 18. 18 times 8 times 50. 50.2 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 That's 0, ano? Plus h times 2 or 2h. Okay. And then followed by 19.5 right here. 19.5 times 8. Ito. Tsaka yun. Sunod ito. Tsaka ito. 59.4 times 10. And then finally 12 times 21.1. So plus 21.1 times 12. So that would be h is equal to okay. So G is equal to ano 49.8. Yun ako na kaya ngayon nagre-record ako. Okay, since the question is the ratio, we're just going to divide F and H, ano? Or H, we're going to divide H by F. Kasi the question is the ratio of hydrogen to octane. So that would be H divided by F. So H divided by F is that would be 49.8 divided by 50.2. They're supposed to get 0.992. Okay. So I will try to find an exercise and then try to answer the exercise and see you on the next video.